Our understanding of the universe often begins with the Big Bang. However, before that moment, a theory known as cosmic inflation proposes an even more dramatic event. This period of exponential expansion shaped everything we see today. It suggests that the universe didn't just expand, it inflated at an unimaginable rate. This rapid growth smoothed out irregularities and laid the groundwork for galaxies and stars. It's a cornerstone of modern cosmology. One of the most mind-bending implications of eternal inflation is the multiverse. If inflation never truly stops everywhere, it could mean our universe is just one bubble in an infinite ocean. Each bubble might represent a distinct universe with its own laws of physics. This concept challenges our perception of reality. It suggests that countless other universes could exist, constantly forming and expanding. The idea moves from theoretical physics into profound philosophical questions. The universe's current accelerated expansion is attributed to dark energy. Could this mysterious force be a lingering echo of inflation, or perhaps a new form of energy driving cosmic evolution? Its nature remains one of science's greatest puzzles. Inflation itself presents many enigmas. What initiated it? What stopped it in our region of space? These questions push the boundaries of our current knowledge, leading us to ponder the very fabric of existence. The idea of eternal inflation paints a picture of endless creation. It suggests a cosmic landscape where new universes are constantly bubbling into existence. This process could be fueled by the very energy that drove the initial inflation. This perspective transforms our universe from a singular event into a continuous dynamic process. It implies an infinity of possibilities, each unfolding in its own unique way. The scale of this concept is truly staggering. So is this a vision of eternal chaos, with universes endlessly spawning without purpose? Or is it the ultimate act of creation, a mechanism for infinite diversity? The implications are profound, touching on everything from physics to philosophy. The universe we inhabit might be just one tiny part of an unimaginably vast cosmic tapestry. What are your thoughts on this grand cosmic dance? Chaos or creation? Tell me, next inflation's bubble burst. Our universe is vast, uniform, and filled with intricate structures. But how did it all begin from a singularity? And why does it look so remarkably smooth on large scales? This question has puzzled scientists for decades. The standard Big Bang model explains much, but it struggles with certain initial conditions. It doesn't fully account for the universe's incredible flatness or the uniformity of the cosmic microwave background radiation. Enter the theory of cosmic inflation, a radical idea proposed in the early 1980s. It suggests that in the first tiny fraction of a second after the Big Bang, the universe underwent an unimaginably rapid and exponential expansion. This expansion was far faster than the speed of light, stretching space itself. It wasn't matter moving through space, but space itself expanding at an incredible rate, driven by a hypothetical energy field. One of inflation's key triumphs is explaining the universe's uniformity. Any initial irregularities or lumps in the early universe would have been stretched out and smoothed over by this rapid expansion. Imagine a crumpled piece of paper being stretched to an enormous size. The wrinkles become imperceptible. Similarly, inflation ironed out the early universe, making it appear flat and homogeneous. Inflation also provides a mechanism for the formation of galaxies and clusters. Tiny quantum fluctuations, microscopic ripples in the fabric of space-time, were stretched to cosmic scales during this rapid expansion. These stretched fluctuations became the initial density variations. Over billions of years, gravity amplified these slight differences, pulling matter together to form the stars and galaxies we observe today. A fascinating implication of inflation is the concept of a multiverse. If inflation is an ongoing process, it might not have ended everywhere simultaneously. Instead, it could continue indefinitely in some regions. This eternal inflation suggests our universe is just one of many bubble universes constantly budding off from an ever-inflating background. Each bubble could have different physical laws and properties. While inflation elegantly solves several cosmological puzzles, it also introduces new ones. The precise mechanism driving inflation, the inflaton field, remains hypothetical and its properties are still unknown. Scientists continue to search for observational evidence that could definitively confirm or refute the theory. The quest to understand the universe's earliest moments is an ongoing journey of discovery. The idea of an inflating universe is a powerful one, shaping our understanding of cosmic origins. It offers a compelling narrative for how our vast, structured cosmos came to be from an infinitesimal point. Balloon or bust? Vote in the comments below. Next, we'll explore inflation's dark side and the challenges it still presents. For centuries, humanity has gazed at the stars, pondering the universe's vastness. We've uncovered incredible secrets, from distant galaxies to the very fabric of space-time. Yet, one of the greatest mysteries remains hidden in plain sight. It's a force that dominates the cosmos, shaping its destiny in ways we are only beginning to comprehend. This invisible, pervasive entity is known as dark energy. It's not dark matter. It's something far more profound and unsettling. Scientists once believed the universe's expansion was slowing down due to gravity. However, groundbreaking observations in the late 1990s revealed a shocking truth. The universe isn't just expanding, its expansion is accelerating. This acceleration implies the existence of a repulsive force, pushing everything apart. Dark energy is the leading candidate for this cosmic accelerator. It acts like an anti-gravity, stretching the very fabric of space. What are the implications of such a powerful, growing force? One terrifying theory suggests a catastrophic end, known as the Big Rip. If dark energy continues to strengthen, its repulsive power could eventually overcome all other forces. First, galaxies would be torn apart, then stars and planets. Ultimately, even atoms themselves would be ripped asunder, leaving nothing but isolated elementary particles. It's a scenario of ultimate cosmic destruction. But is the Big Rip our inevitable fate? The universe's future is far from certain. Other theories propose different outcomes, from a gentle fade to a cyclical rebirth. Dark energy's true nature remains one of science's most pressing questions. Understanding dark energy is key to unlocking the universe's ultimate destiny. Is it a harbinger of doom, or simply an intrinsic part of our cosmic journey? The answer could redefine our place in existence. The universe is a dynamic, evolving entity, constantly revealing new layers of complexity. Dark energy challenges our fundamental understanding of physics and the cosmos. Its influence is undeniable, its origins unknown. We stand at the precipice of discovery, grappling with forces that dwarf our imagination. Will dark energy rip our universe apart, or is there another destiny awaiting us? The enigma continues. The fate of the universe hangs in the balance, influenced by this mysterious force. Will dark energy lead to a cosmic rip, or will its true nature reveal a different, perhaps more hopeful destiny? What do you believe? Is it a rip or a rescue for our universe? Vote now and join the discussion as we explore dark energy's cosmic fate. For centuries, humanity has gazed at the stars, pondering the vastness beyond. We've learned that our universe is not static. It's constantly expanding. But this expansion holds a profound and unsettling secret, one that challenges our deepest understanding of reality. Scientists made an astonishing discovery in the late 1990s. The universe isn't just expanding, its expansion is speeding up. This acceleration defies our conventional understanding of gravity, which should be slowing things down. This means that something powerful is actively pushing the cosmos apart. It's as if an invisible force is constantly adding momentum to the fabric of space itself. This observation completely reshaped our cosmological models. To explain this phenomenon, physicists propose the existence of dark energy. This mysterious entity is thought to make up about 70% of the entire universe's energy density. It's the dominant force shaping the cosmos's ultimate fate. Unlike matter or radiation, dark energy doesn't seem to clump together. Instead, it appears to be uniformly distributed throughout space. Its nature remains one of the greatest unsolved puzzles in modern science. The fundamental question remains, is dark energy truly pushing the universe apart? Or is it something more subtle? Some theories suggest it's a property of space itself, a constant energy density inherent to the vacuum. Others propose it's a new, unknown field or particle. The implications of dark energy are staggering. If its density remains constant, the universe will continue to expand at an ever-increasing rate. This could lead to a future where galaxies become isolated, and eventually even atoms are torn apart. Despite decades of research, dark energy remains an enigma. We can observe its effects, but its true nature eludes us. It challenges our most fundamental theories of physics and cosmology, pushing the boundaries of human knowledge. The universe's accelerating expansion is a cosmic riddle. Is it a push or a pull? Tell me what you think. Next, we'll explore the terrifying concept of energy's big rip. For decades, scientists understood the universe was expanding. However, a groundbreaking discovery in the late 1990s revealed something even more profound. The expansion isn't just happening, it's speeding up. This acceleration presents one of the most significant puzzles in modern cosmology. It suggests the presence of a dominant, unseen force at play. This mysterious entity has been named dark energy. Unlike gravity, which pulls matter together, dark energy appears to exert a repulsive force. It actively pushes galaxies further apart. Imagine the universe as a balloon being inflated. Dark energy is like an invisible pump, constantly increasing the rate of inflation. Current observations indicate that dark energy constitutes approximately 70% of the total mass energy density of the universe. This makes it the most prevalent component of our cosmos. Yet, despite its overwhelming presence, dark energy remains entirely undetectable by direct means. Its nature is one of the greatest enigmas in science. Scientists are employing various methods to understand dark energy. They study distant supernovae, the cosmic microwave background, and the large-scale structure of the universe. These observations provide crucial clues about its properties and behavior. The quest to unravel dark energy's secrets is a frontier of physics. It challenges our fundamental understanding of space, time, and matter. The implications of dark energy are vast. It dictates the ultimate fate of the universe, influencing whether it will expand forever, eventually slow down, or even reverse. Understanding this force is key to comprehending our cosmic destiny. Is dark energy a constant property of space itself, or is it a dynamic field that changes over time? These are questions that continue to drive intense research. The universe is accelerating, driven by this enigmatic force. Is dark energy a cosmic accelerator or an accidental byproduct of fundamental physics? What are your thoughts on this profound mystery? Comment below. Next, we will explore dark energy's cosmic fate. The cosmos is a vast, intricate tapestry, constantly expanding. For decades, scientists have observed this expansion accelerating, driven by a mysterious entity we call dark energy. It's an invisible force, making up roughly 68% of the universe's total energy density. Its nature remains one of the greatest puzzles in modern astrophysics. We cannot directly detect it, yet its effects are profoundly evident across cosmic scales. Understanding dark energy is key to unlocking the universe's ultimate destiny. One chilling theory about dark energy's ultimate power is known as the Big Rip. This scenario posits that if dark energy continues to grow stronger, its repulsive force will eventually overcome all other forces in the universe. It's a future where expansion becomes uncontrollably violent. Initially, galaxies would be torn apart, their gravitational bonds no match for the escalating dark energy. Then, individual stars and planets would be ripped from their systems. The very fabric of space-time would begin to unravel. As the Big Rip progresses, the destructive force would intensify, reaching even smaller scales. Atoms themselves would be stretched and pulled apart, their fundamental particles unable to hold together. This would lead to a complete disintegration of all matter. The universe would not merely cool down or fade away. It would be violently shredded into its most basic components. Every structure, every particle would cease to exist as a coherent entity. It's an end far more dramatic than a slow freeze. The Big Rip remains a theoretical possibility, heavily dependent on the precise properties of dark energy. Current observations suggest dark energy's density might be constant, which would lead to a different, albeit still bleak, end known as the Big Freeze. However, the possibility of an ever-increasing dark energy density keeps the Big Rip on the table. Scientists continue to gather data, hoping to precisely measure dark energy's behavior and predict our cosmic fate. So, is the universe destined for a violent Big Rip, or will it meet a different, perhaps gentler end? The answer lies hidden within the enigmatic nature of dark energy itself. Its secrets hold the key to our cosmic future. Will dark energy rip apart everything we know, or will its influence stabilize? Rip or rescue? Tell me your thoughts. Next, we'll delve into quantum foam and the very fabric of reality. Mars, our enigmatic neighbor, holds secrets far beyond its rusty surface. Its atmosphere, thin as it is, harbors powerful forces that shape its very landscape. We often think of Mars as a barren, quiet world, but beneath that perception lies a dynamic, often violent environment. A key player in Mars's atmospheric drama is its carbon dioxide ice. Found at the poles, this frozen gas undergoes a remarkable transformation with seasonal changes. As temperatures rise, this solid CO2 doesn't melt, it sublimates, turning directly into gas. This process is not just a gentle thaw, it's an explosive release of energy. The rapid sublimation of vast quantities of CO2 creates immense pressure differentials. These pressure gradients are the primary drivers of Mars's powerful winds. These aren't just breezes, they are planet-spanning dust storms that can engulf the entire globe for months. The energy released can be truly staggering. Beyond the winds, Mars presents a hostile environment. Its thin atmosphere offers little protection from solar radiation, a constant threat to any potential life or human missions. The planet's surface is constantly bombarded, and the dust storms exacerbate these conditions by lifting abrasive particles high into the air. Mars, in a sense, actively resists external influence. Are these Martian phenomena predictable, or do they represent an unpredictable peril? Scientists meticulously track these atmospheric shifts using orbital data to forecast major dust events. While patterns emerge, the sheer scale and intensity of some storms remain a significant challenge for future exploration. Understanding these forces is crucial for safe passage. Mars's ability to generate such extreme conditions from its own frozen resources speaks to its unique resilience. It's a world constantly reshaping itself through these powerful atmospheric processes. The interplay of ice, gas, and solar energy creates a planetary system that is both awe-inspiring and formidable. From the sublimation of CO2 ice to the raging global dust storms, Mars is a planet of extremes. Its atmospheric dynamics are a testament to the raw power of planetary forces. This constant battle against the elements defines much of what we observe on the red planet. Wind warrior or weak? Tell me. Next, space-time matrices. The universe we inhabit is vast beyond comprehension, yet it might be just one of countless others. Imagine a cosmic ocean, where our universe is merely a single drop. This profound idea is known as the multiverse. For centuries, humanity has pondered the uniqueness of our existence. Now, scientific theories suggest that our reality might not be singular at all. The concept of parallel universes challenges our most fundamental assumptions. One of the most compelling theories supporting the multiverse is cosmic inflation. This theory describes a period of extremely rapid expansion in the early moments of our universe's birth. It explains many observed features of the cosmos. However, some models of inflation propose that this rapid expansion didn't just happen once. Instead, it could have occurred an infinite number of times in different regions, creating an endless array of bubble universes. Each bubble could be a universe unto itself. If these bubble universes exist, the implications are staggering. With an infinite number of realities, every conceivable possibility might play out somewhere. This includes the existence of parallel versions of ourselves. In one universe, you might be living a slightly different life. In another, your choices could have led to entirely different outcomes. The idea of a twin out there is not just science fiction. It's a fascinating consequence of these theories. The multiverse theory multiplies the enigmas of existence. It raises profound questions about identity, destiny, and the very nature of reality. Are these other versions of us truly us, or just echoes of potential? While direct evidence remains elusive, the mathematical frameworks supporting these ideas are robust. The concept continues to fuel scientific inquiry and philosophical debate, pushing the boundaries of our understanding. What do you think about the possibility of a parallel you? Is it an exciting prospect or a mind-bending trick of cosmic scale? Share your thoughts below. Next time, we'll delve deeper into how these cosmic bubbles might interact. Prepare for a discussion on their potential collisions and what that could mean for our own reality. We often perceive time as a steady, unwavering river. Yet at the universe's most fundamental scales, this perception might be profoundly mistaken. Scientists are exploring a concept known as quantum foam, a realm where reality itself might be in constant flux. This theoretical landscape suggests that space-time isn't smooth, but rather a turbulent, bubbling sea. These microscopic fluctuations could hold secrets about the very nature of existence. What if these tiny bubbles are not just empty space, but active participants in shaping our reality? Imagine space-time not as a rigid grid, but as a dynamic, ever-changing tapestry. Quantum foam proposes that at incredibly small distances, this fabric is constantly tearing and restitching itself. These ephemeral tears and connections are the bubbles of the foam. These quantum fluctuations are thought to be incredibly energetic and fleeting. They exist for fractions of a second, appearing and disappearing in a chaotic dance. This constant activity challenges our classical understanding of a stable universe. The most intriguing aspect of quantum foam is its potential interaction with time itself. If space-time is indeed bubbling, these microscopic distortions could locally warp the flow of time. This means time might not pass uniformly everywhere. Within these quantum bubbles, time could speed up, slow down, or even momentarily cease to exist. This concept pushes the boundaries of our current physics. It suggests that time as we know it might be an emergent property of this underlying chaos. Understanding quantum foam could unlock profound insights into the universe's deepest enigmas. It might explain phenomena like dark energy or even the very beginning of the cosmos. The implications for our understanding of reality are immense. This theoretical framework offers a new lens through which to view the universe. It suggests that the smooth reality we experience is merely an average of countless quantum events. The true nature of existence might be far more dynamic and unpredictable. The concept of quantum foam remains largely theoretical, a frontier of modern physics. Researchers are developing new mathematical models and experimental approaches to probe these incredibly small scales. The challenge lies in observing something so fleeting and minuscule. The enigmas surrounding quantum foam continue to fizz with possibility. It represents a profound journey into the very foundations of our universe. Is time a fundamental constant, or merely a surface phenomenon? The idea that quantum foam hides secrets about time is a captivating one. It forces us to reconsider everything we thought we knew about the universe. The universe's deepest truths might be found in its smallest, most chaotic corners. Is this a secret hidden deep within the fabric of reality, or just a surface ripple in our understanding? Tell me your thoughts. Next, we'll dive deeper into foam's cosmic chaos. Imagine the universe not as a smooth, continuous expanse, but as something far more chaotic at its most fundamental level. Scientists ponder if the very fabric of space-time might be constantly bubbling and popping. This concept is known as quantum foam. It suggests that our perception of a stable, unchanging reality could be an illusion at the smallest scales. The universe might be a turbulent sea of fleeting energy and geometry. This idea challenges our deepest understanding of existence. At scales unimaginably small, far beyond atoms or even subatomic particles, the universe might be a turbulent sea. Here, space and time are not fixed, but fluctuate wildly, creating and annihilating tiny, ephemeral bubbles. This is the essence of quantum foam. It suggests that empty space is never truly empty. Instead, it's a seething cauldron of virtual particles and energy, constantly appearing and disappearing. This microscopic turmoil could be the true nature of reality at its most fundamental quantum level. The idea of quantum foam emerges from the attempt to reconcile two pillars of modern physics: quantum mechanics and general relativity. Quantum mechanics describes the universe at the smallest scales, while general relativity explains gravity and the large-scale structure of spacetime. When these theories are pushed to extreme conditions, like the Planck scale, they predict bizarre phenomena. Quantum foam is one such prediction, where the smooth geometry of spacetime breaks down into a frothy, indeterminate mess. If quantum foam is real, it has profound implications for our understanding of gravity, black holes, and the very beginning of the universe. It could explain why gravity is so weak compared to other fundamental forces. The constant fluctuations might dilute its strength. The existence of quantum foam remains a theoretical enigma, yet to be directly observed. Its scale is so incredibly small that current technology cannot probe it. However, physicists continue to devise experiments that might indirectly reveal its presence. Scientists are exploring various avenues to detect the subtle effects of quantum foam. One approach involves looking for tiny distortions in light traveling over vast cosmic distances. These distortions could be caused by the fluctuating nature of spacetime. Another area of research involves high-energy particle collisions, hoping to glimpse effects that deviate from standard physics. The quest to confirm or refute quantum foam is a journey into the deepest mysteries of the cosmos. Is our reality built on a solid foundation, or is it merely a grand illusion of countless popping bubbles? The question of quantum foam challenges our perception of the universe. Bubble or bedrock? Vote next. Foam's quantum secrets. We often perceive reality as smooth and continuous, a stable stage for all existence. But what if at its most fundamental level, reality isn't so solid? Imagine the very fabric of space-time not as a calm ocean, but as a turbulent, effervescent brew. This is the mind-bending concept of quantum foam, a theoretical landscape where the universe itself bubbles and fizzes. It suggests that our smooth perception is merely an illusion, masking a chaotic quantum underworld. To understand quantum foam, we must journey to the Planck scale, an unimaginably tiny realm. This is the smallest possible unit of length, time, and mass, far beyond anything we can directly observe. At this scale, the rules of classical physics break down completely. Here, quantum mechanics takes over, dictating that even empty space is not truly empty. Instead, it's a seething cauldron of virtual particles constantly popping into and out of existence. Quantum foam proposes that space-time itself undergoes these quantum fluctuations. It's not just particles appearing and disappearing. It's the very geometry of space and time warping and twisting. Think of it like the surface of boiling water, constantly forming and collapsing bubbles. These tiny, ephemeral bubbles of space-time are what we call quantum foam. They represent a chaotic, ever-changing structure at the universe's most fundamental level. If quantum foam is real, it profoundly challenges our understanding of reality. Our smooth, predictable universe would be an emergent property averaged out from this underlying chaos. It suggests that gravity, and even the dimensions we perceive, might arise from these quantum jitters. This concept is a cornerstone of theories attempting to unify quantum mechanics with general relativity. It's where the very nature of existence becomes a profound enigma. Scientists are actively exploring ways to detect the subtle effects of quantum foam. While direct observation remains impossible, researchers look for minute distortions in light from distant objects or subtle changes in gravitational waves. These experiments push the boundaries of our technological capabilities. The existence of quantum foam could explain some of the universe's deepest mysteries, from the nature of black holes to the very beginning of time. It's a frontier where physics meets philosophy. So, is reality a stable bedrock, or is it a frothing quantum bubble bath? The answer remains one of science's most compelling questions. The implications are staggering, suggesting a universe far stranger and more dynamic than we can easily comprehend. What are your thoughts on this incredible idea? Do you think reality is fundamentally foamy or solid? Comment below. Next, we'll delve deeper into quantum foam's most intriguing secrets. Imagine the very fabric of space and time, not as a smooth, continuous sheet, but as a turbulent, frothing ocean. This is the concept of quantum foam, a theoretical realm existing at scales far smaller than atoms. It suggests a universe teeming with activity, even in seemingly empty space. At these infinitesimal dimensions, the rules of classical physics break down. Instead, quantum mechanics dictates a chaotic dance of energy and particles. This constant flux might hold profound secrets about the nature of reality itself. Quantum foam envisions space-time as a seething cauldron of virtual particles constantly popping into and out of existence. These fleeting entities create tiny, transient warps and ripples in the fabric of space-time. It's like a cosmic effervescence, always in motion. These microscopic bubbles are not static. They appear and vanish in an instant. Their ephemeral nature challenges our conventional understanding of a stable, predictable universe. This dynamic interplay is fundamental to the theory. Could this quantum foam be more than just a background hum of the universe? Some theories propose that these space-time fluctuations are intimately linked to the very nature of time. Perhaps the flow of time itself emerges from this microscopic chaos. If space-time is constantly warping and unwarping at the quantum level, how does this influence our perception of time's arrow? It raises questions about whether time is a fundamental entity or an emergent property of the universe. The implications of quantum foam extend far beyond theoretical physics. Understanding its role could unlock deeper insights into gravity, black holes, and even the origins of the universe. It offers a new lens through which to view the cosmos. Exploring this concept pushes the boundaries of our knowledge. It suggests that the most profound truths about existence might be hidden in the smallest, most turbulent corners of reality. Does quantum foam merely represent the surface of reality, or does it conceal the ultimate secrets of time? The answer could redefine our understanding of the universe. Is it a secret waiting to be uncovered, or just a theoretical surface? Drop your take in the comments. Next, we'll dive into foam's cosmic chaos. Our universe, vast and mysterious, might not be alone. Imagine an infinite ocean, not of water, but of countless other universes, each a distinct bubble of reality. This concept, known as the multiverse, challenges our perception of existence. These cosmic bubbles are not static. They are in constant, albeit slow, motion. What happens when these colossal, unseen entities inevitably meet? The implications are truly mind-boggling to consider. The idea of universes colliding isn't just science fiction, it's a fascinating hypothesis in theoretical physics. Picture two immense, invisible bubbles drifting closer and closer in a higher dimension. Their boundaries touch, then begin to merge. This isn't a gentle embrace. It's a monumental event, a cosmic mashup on an unimaginable scale. The very fabric of space-time from each universe could interact, intertwine, and even exchange properties. When these multiverse bubbles crash, the outcome is a subject of intense speculation. Could such a collision lead to utter annihilation, tearing apart the very structure of both realities? Or does it spark something entirely new? Some theories suggest these collisions are catalysts for creation. They might generate new universes or perhaps even reset existing ones. It's a cosmic dance between destruction and rebirth, a grand cycle of existence. The enigmas surrounding these potential collisions are profound. How would such an event manifest within our own universe if it were to happen? Could it leave behind subtle imprints or cosmic scars that you might one day detect? Scientists continue to explore these possibilities, seeking clues in cosmic background radiation or gravitational waves. Each collision, whether destructive or creative, adds another layer to the grand tapestry of reality. The thought of universes colliding forces us to reconsider everything we know about existence. It pushes the boundaries of our understanding, inviting us to ponder the true scale and nature of the cosmos. Is the universe we inhabit merely one of many, constantly interacting in ways we can barely comprehend? The answers remain elusive, hidden within the vastness of the multiverse. Crash or cosmic? What do you think happens when universes collide? Comment below. Next, we'll delve into the multiverse's dark energy,